Okay, today we're going to do parabolas. I believe is 10.5, but I could be incorrect. We're going to do horizontal and vertical at the same time. Vertical I'm going to do first because we've looked at vertical parabolas before and we called these quadratics. It'll look something like this is in vertex form. So when we were in vertex form before, we said y equals a parentheses 1 over b x minus h squared plus k. We're not going to be dealing with b's when we're doing this, so we're going to kind of throw this out. And we're actually going to be calling the a value something different. When you see the a value, we're going to call it 1 over 4p. And I'll explain that a little bit more when it comes up. But whatever your a is, what you thought of as a before is now 1 over 4p, okay? So when we're in this form, it tells us the vertex of the parabola. So our vertex is going to be at hk, which we already did before. And then the p-value is going to help us find the focus. So we've done this before. When we're doing this guy right here, if I was going to graph this out, my vertex would be at 3, 4. So I would graph it by going to 3, 4. I would look at the a value. The a value is positive, which means it's going up. It's not reflected across the x-axis. And because it's a 2, that means that it's vertically stretched by a factor of 2. So what's happening is it's going like this. Now that's what we did before. Now we're going to do things slightly different. We're going to find the vertex, which we already did. We're going to find the focus. I'm going to go on to another paper because I ran out of room. Which focus is 1, and we were doing foci before because we had more than one. Focus on a vertical parabola is going to come from h comma k plus p. And then we're going to do the directrix. Directrix is it's a line. It's like a second focus. The reason that I say that is the way that we find the directrix on this is we do y equals k minus p. So before, when we were trying to find two focus on a hyperbola or on an ellipse, we did plus and minus. On this value, what we're going to do is we're going to do plus for the focus. Minus is going to be the equation of a line, but it's still going to be, we're going to be finding the second value. So to find the p, what I need to do is I need to set this equal to what I have where my a was, which is 2. So I'm going to say 1 over 4p equals 2. 2 as a fraction is going to be 2 over 1. And I'm going to multiply 1 times 1, which gives me 1, and 2 times 4p, which gives me 8p. Now I'm going to be able to figure out what p is by dividing by 8. And p equals 1/8. So the focus on the example that I had a vertex of 3, 4 is going to be 3, 4 plus 1/8. 4 as eighths is going to be 32 eighths, so 33 eighths. That value is going to be very close, but right inside of the parabola that I just drew right here. Now my directrix is going to be y equals k, which is 4, minus p, which is 1/8. So again, 4 as eighths is 32 eighths, minus 1 is going to be 31 eighths. Y equals 31 eighths. So what I'm going to do is I'm going to go to that value, which is going to be very close, but like right here, and I'm going to draw a dashed line. It does not go through my vertex, it's just very close underneath it. Okay. And the last thing that I'm going to ask you for is the axis of symmetry. Axis of symmetry we did before, so it should be fairly simple. It's just x equals the h value. So on this one it's x equals 3. The axis of symmetry is where I can cut it in half and fold it on top of itself. So that line right there. And that's it. And we're done. So now we're going to do horizontal. Horizontal is going to be very similar, but it would look like this. So notice what changed here. On the vertical one, my x is squared. On the horizontal one, my y is squared. So now, for the horizontal one, it's in the form of so the k is always with the y, so don't get confused and mark these backwards. The k is still with the y. The k, if I subtracted it over, would be with the y here. The h is always with the x. The h is with the x here. If I subtracted it over, it would be with the x. Okay? So our vertex is still hk. So on this example, our vertex would be 9, 7. And that's what I mean by don't get them backwards. Okay? The directrix on a horizontal one is going to be h plus p comma k. So on this one, I'm going to find the p by setting this equal to 1 over 4p. So 1/4 equals 1 over 4p. I'm going to multiply. 4p times 1 is 4p. 4 times 1 is 4. Divide by 4. And I get p equals 1. So the directrix on this example is going to be 9 plus 1, or 10, comma 7. Oh, I did that backwards. I apologize. That was the focus. I don't know why I said directrix. That's the focus. I apologize. Don't make fun of me. Don't bully me for that, okay? Directrix for this one is going to be x equals h minus p. So again, p was 1, h was 9, so it's going to be x equals 9 minus 1, which is 8. And then my axis of symmetry is y equals, and it's the y value at the vertex, which is k. So on this example, it would be y equals 7. The axis of symmetry always has to go through the vertex. So being as this is a horizontal one, it's going to go sideways. So in order to have a folding line, it needs to be y equals something. This one was a vertical one, it went up and down. So in order to have a folding line, it had to be x equals something. Hopefully that makes sense. So my vertex is 9, 7. Because the p value is positive, it's going to be opening to the right. My focus is at 10, 7, so 1 unit over. My directrix is at x equals 8, again 1 unit over. And my axis of symmetry goes right through there. So hopefully that makes sense. This is 9 minutes long. I'm not sure if it's going to upload. Hopefully it does. When we have questions, let me know.